Hello, my name is Wenming Yi. I am a technical evangelist on the Windows Azure team. We just released a public preview of Windows Azure HDInsight service. I am here to help you to understand the new Apache Hadoop-based service and also what you can do with it. As many of you already know, Hadoop is a very popular distributed data processing and querying tool. It is used by many Web 2.0 companies for their big data needs, such as Facebook. This video series will consist of about 15 videos about HDInsight, and this is the first in the series. There are additional videos that are coming. So in the first two videos, part 1 and part 2, we'll explain how Hadoop works as a big data processing tool through a PowerPoint presentation, and the rest of the series will consist of quick how-tos and scenario-based demos. Please feel free to watch them out of order. They're designed to be standalone. Our presentation is divided into 3 sections. We'll take a look at what big data means in today's context in terms of use scenarios. Then I'll explain the architecture and ecosystem of Hadoop. This is the first video, and then in the second video we'll cover how Windows Azure HDInsight works as a Hadoop service. And we'll take a closer look at the programming tools that are available. By the end of the presentation, you have a good understanding what big data is and also how HDInsight along with Windows Azure can be used together to tackle big data problems and also to support important business decisions based on big data processing. This slide is a good starting point to understand big data. These are the trends that are triggering the big data revolution. Most of us are already familiar with these trends, but we need to take another look at them from news perspectives. Almost everyone now has one or more mobile devices, and the world currently has about 5.5 billion devices, which reaches out to 70% of the world's population. Social networks such as Facebook and Twitter, they have 2 billion users, and they're generating a huge amount of data every minute and every second, and they're growing fast. As a human society, we'll create 7.2 zettabytes of information per year by 2015. Now that is only 2 years away. In addition to the data that humans are creating, the next growth area is sensor networks, or Internet of Things. We'll have more than 10 billion networked sensors in the very near future. Another important thing to note is that all these devices are connected to the internet, and each of them are generating large amounts of data that we will have to collect and analyze. At the same time, we're seeing 2 other trends that are going in the opposite direction. The cost of compute and storage has gone down dramatically. These 2 trends are also helping to grow the big data industry. Here's an example of mine. 20 years ago, 1 megabyte of storage cost about $1 to store. Now it is pennies for 1,000 megabyte. And that is a difference of a few million times. When you see an explosive growth of data and rapid decrease of storage prices, there are suddenly opportunities to invest in big data. In return, we're getting not only information, insight, but also increased productivity and competitiveness. Things that we weren't able to do before suddenly all became very much feasible. Here are the 3 characteristics of big data: volume, variety, and velocity. Let me give you an example of each. Most people understand large volumes of data from their digital media collections or maybe even their ever-growing email inboxes. And of course, that petabytes of information that many companies are storing. And variety speaks for the second property of big data, and there are many different types of data out there, and they can be structured or unstructured, meaning that they don't necessarily have well-defined schemas. And finally, the velocity of data. Social network is probably the best way to explain velocity of data, and there are human activities on the social network around the world every minute and every second. If you are running such a service, it simply cannot go down for maintenance. As you can see, there's a huge challenge to be able to deal with these properties of big data and still maintain a good service level without professional help. Big data is becoming a big opportunity for individuals and companies, and there are big investments being made in the areas in terms of innovative tools, hardware, and consultancy. That means for us developers, learning big data science is becoming a valuable skill to have. There are many application scenarios for big data, but I'd like to focus on 3 of them today. The first one is about data warehousing in the enterprises. Traditionally, during the extract, transform, and load phase of data warehousing, we throw away a lot of information because they simply cannot be stored with low cost. But with Hadoop, it uses commodity hardware to store data. It makes it much cheaper to store what we previously called data exhaust, and we used to throw them away. And even though these log files generally consist of very low information density, by using big data tools, we're still able to extract very valuable information cost effectively. Enterprises are increasingly to start looking at Hadoop as a solution to keep more of their data exhaust and extract values. And more importantly, as more sophisticated technologies become available, we can data mine historical data with them. The second scenario is what we discussed earlier, Internet of Things. In one of the video series, we'll show you how we were able to use a wireless device less than $20 to collect and extract information from a car to look at engine performances, and we like to show you more interesting examples of sensors and devices. Please do keep in mind many of these sensors and devices are actually connected to the internet at all times, just like your GPS. They emit data at a much faster rate than humans can tweet or post on their Facebook. The third scenario is about collective intelligence and predictive analysis. By now, the big data industry already started to understand how to store data at a very large scale, but predictive analysis of the data that we store is really the next difficult problem to solve. Once again, the volume, variety, and velocity of big data do not make this much easier. There are a tremendous amount of data that needs to be stored and analyzed in real time interactively and use batch processing using machine learning and parallel algorithms. So in some of these later videos, we'll look at the simple machine learning examples from the Mahal package, which we can run on top of Hadoop. One of these examples is the recommendation engine that uses information you collected about your user, just like Netflix. And you can use that collective behaviors to predict what your users might do next. Now let's dive into how Hadoop works as a big data tool. It essentially employs a tried-true tactic for solving really large problems called divide and conquer. This is to take a large problem and try to solve it using parallelism, or cut large problems into smaller problems to solve. That makes Hadoop a distributed parallel system. So in a typical Hadoop cluster, it consists of many machines running in parallel to act as a single system. It uses many processors to do compute and many individual storage devices to store large amounts of data. In this diagram, you'll see Hadoop works exactly that way. It has 2 layers, the HDFS layer, or Hadoop distributed file system for storing the data, and a programming layer. The programming layer uses the MapReduce programming pattern to map computation onto each individual machines in a large cluster to do the work. The Hadoop file system has redundancy built in. It keeps 3 copies of your data in case there is a failure in the system somewhere. If one of the compute nodes dies, the MapReduce layer can still find another copy of your data to process. Here's a closer look at how MapReduce works. The MapReduce call is like the assembly language of big data. It is a very low-level API. Most of the time, you will not be using it directly. Instead, you will be using higher-level programming languages like Hive or Pig, which we'll demo in another video. It is still a good idea to see how MapReduce works. The key to MapReduce is about minimizing the movement of data inside your cluster. The job tracker understands where all the data blocks are and can send operation code to the node that it contains the data it needs to operate on. And it tries to avoid copying data across the network. Here's a simple example of MapReduce, word count. In order to do word count in a MapReduce fashion, or in parallel, you will need to give each computer in a cluster a portion of the data to operate on. So in this case, we have a map function that gets loaded onto each of the machines to operate on the data that already resides there. And finally, a reduce function that collects statistics back from each of the machines. As you can see, this is really a very simple pattern for distributed computing, but it can get very complex very quickly when you operate on multi-step real data problems. Luckily, we have higher level programming languages that can produce steps for us automatically. So in this video, we covered the basics of Hadoop and big data. In the next video, we'll cover how HDInsight works.